Good day. In this lecture, we will look at programming language in general. After that, we'll go to algorithm and flowchart. So, a programming language is basically involve a set of vocabulary and grammatical rules for instructing a computer to execute or perform a specific task. Programming language usually refers to high-level languages such as basic C, C++, COBOL, and so on. Each language has a unique set of keywords and special syntax for organizing program instructions. High-level languages are a lot simpler compared to spoken language. However, they are more complex than the machine language, which is understood by the hardware or the computer. And each CPU has its own unique machine language. In between machine language and high-level languages is the so-called assembly languages. Assembly languages are a lot similar to machine language. They're much easier to, however, they are much easier to program because they allow a programmer to substitute names for numbers. Whereas machine language, we only use zeros and ones, in other words, binary numbers. Above the high-level language, we also have the what's known as the fourth generation language, 4GLs. These languages are the closest yet to the spoken language. When you have a program written in high-level language, in order for the computer to execute the instruction, we have to compile or interpret the program, and we can read. You can do further reading on compilation and interpretation. Just search the internet for these two keywords. In this figure, we have hierarchy of programming languages. We have the computer hardware at the bottom. It only understands machine language, binary, zeros and ones. When you have assembly language, it has to be converted to machine language using a special program called assembler. Programs written in high-level language, such as C, must be converted to machine language using a special program called compilers. Algorithm and flowchart. Algorithm is basically a set of logical steps to solve a problem. You describe how to solve a problem, and flowchart is the pictorial or graphical representation of algorithm. For any problem, the solution involves any combination of these three basic building blocks. It may involve sequential execution, where instructions are performed one after the other. The solution may involve branching operation. It may also involve looping operation, where a block of instructions is repeated several times. In this table, we have for sequential execution block, the unconditional transfer is represented by the arrows. You must follow the arrow. The direction can be left, right, upward, or downward. Next, we have the input-output function or IO function. The flowchart symbol is a parallelogram. For processing, the flowchart symbol is a rectangle. These flowchart symbols are available from Microsoft Word. You don't have to draw them, you just get it from the MS Word. The second basic building block is the branching operation. The function is basically involve conditional transfer, where the flowchart symbol is this diamond shape. You enter the diamond, you test here. Let's say if the test is true, go to the left. Otherwise, if the test is false, go to the right. For looping operation, we have conditional loop and counted loop. First, look at conditional loop. This is the basic flowchart for conditional looping. The loop continues as long as the condition here is true. Once this condition is false, exit the loop. Counted loop operation. This is the flowchart symbol. In this flowchart symbol, we set up the looping operation, when to start, when to stop, and what's the increment for the loop control variable. Don't worry too much. All this will become a lot clearer once we go to the actual programming. In this example, we have the sequential execution of instructions. So the problem is construct an algorithm and draw the flowchart to compute mass of a solid sphere, diameter small d, density capital D. On the left, we have the algorithm. You always begin with start. Second step is going to be get diameter small d and density capital D. Next, we compute volume of sphere. D on 2 is basically the radius of the sphere. After that, we calculate mass, which is density times volume. Finally, we stop. On the right, we have the corresponding flowchart. These two symbols are for start and stop, also available from MS Word. Get or read small d and density, compute V, next compute M, stop. You don't compute or calculate here. The symbol itself tells the process where we calculate V and M. Branching operation. Construct an algorithm and flowchart to find if a number x is negative, positive, or 0. So this is the basic template for branching operation. In this case, there are three options. Start, get the number x. Is x less than 0? If yes, then x is negative. Display on the screen that say x is negative. If no, we need to test x is equal to 0. If yes, x is 0, display 0. Otherwise, display x is positive. Whenever we ask question, this is where the diamond is. So this is the starting of the branching operation. Here 1, 2 here. So n a branch for this diamond, n branch for this diamond here. Stop. For branching operation, the algorithm is not immediately clear. It's a lot easier to look at the flowchart for branching operation. This is much clearer. Start, read x, test x negative. If yes, display negative, follow the arrow, stop. Else, the next test is x is equal to 0. If yes, display x is 0, follow the arrow, stop. Otherwise, for this test, x has to be positive, display positive, follow the arrow, stop. Counted loop operation. Write an algorithm and flowchart and draw the flowchart to obtain the summation of this series x squared, x from 1 to 10. In other words, x 1, 2, 3 up to 10. This is the more or less standard template for algorithm of counted loop operation. Start, initialize sum to 0. Loop, x is going to start from 1 to 10. Each loop, increment x by 1. If x is greater than 10, then exit the loop. So inside the loop, we add the latest value of x squared to the previous value of sum. So at the end of the loop, we have the cumulative sum. This is the flowchart for counted loop operation. Initialize sum to 0. X start with 1, ends with 10. Each loop increment x by 1. Once x is greater than the stopping value 10, exit the loop and display the cumulative sum. In this case, x is also known as the LCV, loop control variable. The number of loops is given by this equation. Stop minus start divided by step plus 1. So in this case, it's going to be 10 minus 1 over 1 plus 1 is 10. So this is going to be 10 loops. And finally, for the same problem, we will use conditional loop operation. Start, initialize x to 1, sum to 0. We say here conditional loop in the bracket. The loop continues as long as x is less than 11. So inside the loop, increment sum by x squared, increment x by 1. When this is true, perform this operation. When this is false, out of the loop, end loop. At the end, we display the cumulative sum. This is the flowchart for conditional loop. Start, initialize. The process here is we initialize x to 1, sum to 0. We test, is x less than 11? Yes. Increment sum, increment x. Keep on looping until this is false. And this is false, exit the loop, display the cumulative value of sum. In the next lecture, we'll start with programming with C. Thank you.